we're doing the process has two steps. The first step is reacting chlorine with ethylene to give us dichloroethane, and the second step was the cracking of dichloroethane to give us vinyl chloride and HCl. And what we have specified is 300 million pounds per year of ethanol with a 90% operating factor, and we calculated that to come out in SI units to 46,000 kilograms per hour. So we have specification on how much vinyl chloride to make, and that vinyl chloride will come from the second reactor, the cracking, and that specification leads us to how much dichloroethane. So we used the second reactor, we specified what molar flow rate of the component we would have, that we have 46,000 vinyl chloride molar flow rate, sorry, mass flow rate, correction, mass flow rate. And from that, we figured out how much dichloroethane we must be feeding. So the result was, if we go to composition, and if we go to changes to, well, actually this is component. So we need to specify 115,620 kilograms per hour of vinyl chloride, of dichloroethane. We now need to make this dichloroethane, and that will happen with the first reactor. So to finish that, let's bring in the first reactor. A conversion reactor again. So start where we stopped last time when we just starting. Let's name that reactor. And again, we have specified temperature, so it's not going to be adiabatic. We'll have two inlets, ethylene and chlorine. So let's, actually we can just type them and we'll create the streams for us. We can type ethylene, and you can see the moment that I type ethylene, an ethylene stream was created. Let's create a second stream, CO2. Hopefully it is blue. And a CO2 stream is created.
CO2 or CO2?
If you remember, we have chlorine involved, right? So it should be CO2.
Oh. It sounds like you're saying CO2.
Okay, I was meaning to say CO2 if you misheard, sorry. Put some space between them. And products. So we put again two streams. Let's call it VR1 for reactor. Oh. Okay, delete this. So click on vapor outlet, VR1, and well, I put exclamation point instead of 1, okay? And that's a fictitious stream, I believe, but yeah, I'm pretty sure that's fictitious. LR1. And we need the duty. So we need to put an energy stream. So let's call it R1 duty. So this way I put all the streams that we'll have in this reactor. And I think, because I correct the typo, I still have that. Here we go. I just read the wrong one. All right. I'll delete this and I'll just type here VR. Okay, now, I know how much vinyl chloride, sorry, how much dichloroethane I want to make and have product in VR1, right? I don't know how much chlorine and ethylene I need. In your project, it's important that you feed components in the proportion that your literature has. Okay, the conversion that you get certainly depends on the relative mole fractions of the components of the feed. So, let's say I had in the source that it is 10% higher chlorine. Then I would need to have the mass, let's say it's by mass, I would need to have the mass percent of chlorine 10% higher than stoichiometric. On the other hand, so I have to do something like that, and with the adjust, I can only change one factor. Okay? I will specify how much dichloroethane I'm getting here, and I want to be changing both, so I can't be changing both with an adjust. Adjust is also only one target variable that I can be changing. So how can I manage it? The way is now to introduce another functionality, the set key. And that is a lot, this brings really no convergence issues. The set key allows to make one variable a function of another, but it has to be a linear relationship on it. It cannot be any different. Also, the units must be the same. So I can have mass of this stream set as a function of mass of this stream, or vice versa, or moles of this stream, vice versa. For this simple example, let's keep it simple, that we're going to be feeding chlorine and ethylene at stoichiometric amounts. I will choose one of the two to adjust. Let's say I'll choose ethylene to adjust. So I will set that the chlorine stream will have the same molar flow as the ethylene stream. That make sense? I can only adjust one variable.
Okay.
Okay? I cannot specify this, adjusting both of them. So what I'm going to do with the set, I will relate those two. I'll relate chlorine to be depending on what ethylene is doing. And then I will use the adjust to find the right amount of it. Okay? So let's first do the set. So in this case, I'll do equimolar. No excess. If you have excess, you're going to put 1.05, 5% excess, whatever, right? So let me bring over a set key, set component. So click on the S, move it between the two, assuming that I can grab it. Come on, leave. Oh, that's it. Thank you. Let me exit out of there. Thank you. Okay. So move this S somewhere between ethylene and chlorine. And the first thing is target variable, the other variable is source variable. The target variable is the variable I'm going to be changing. So if I'm going to be changing the chlorine on the basis of ethylene, my target is going to be the chlorine stream. So select variable, chlorine, and obviously if it's stoichiometric, it must be equal molar flows. So I will specify the molar flow of this and click OK. So that's the target. And the source is going to be the ethylene, and I'm not specifying what. It has to be molar flow rate of the stream. And then you go to parameters. The default is equality. So right now you see it's the expression is y, which is the one we are setting, the chlorine, is equal to multiplier times ethylene plus NO3. Okay? In this case, if I want stoichiometric, the multiplier is 1. If I wanted 5% molar excess chlorine, I would use 1.05 multiplier. Clear, everyone? And let's define the temperature and pressure of those two streams. So if we look at what we had in class, let's define it. For the first reaction, the conditions were °C and looks like 1.5 atmosphere. Yeah, 90°C, 1.5 atmosphere. Oh, and someone asked me, and sorry I didn't have a chance to return the phone call, I just got sidetracked. How do you specify how do you get your bioreactor to be at the specified pressure? You specify the feeds at that pressure that go to the bioreactor, your bioreactor will be at that pressure. Okay, just specify the feeds to be at that pressure. And you will be pumping up or using valves to lower pressure of feeds. Okay, so we need 90°C and 1.5 atmosphere to both of those streams. Let me do that. Ethylene, I'll put 90°C and 1.5 atmosphere. Obviously, the mass flow is going to be adjusted by the adjust, but I also need to specify the composition. So in each of those streams, I need to specify temperature, pressure, and composition. So for composition, I'll go here, and this is the stream that is ethylene, so I'll put mole fraction 1 for ethylene, and click OK. It's still not specified because I don't have the total flow rate, which will be figured out by the adjust. I'll do the same thing for the chlorine stream. So click the chlorine, temperature 90, pressure 1.5 atmospheres, not kilopascals, and go to composition. Okay, let me try something. Let me save it. Well, let me see. All right. So the next thing is composition, and this one is chlorine. So you put one on chlorine, and click OK.
Are we okay, we're following?
All right, let me see.
Yes.
Oh, no, I need to reset the computer. Yeah.
Just try it.
Yeah, no, I need to reset the computer.
You don't have to restart it, you just have to log out.
Yeah, no, I can't. I have to restart. Yeah, no, I can't.
You can click the window button plus and it should
I just zoomed in.
it magnifies the thing.
Yeah. Window plus.
Window and plus.
Like the window key. At the same, you have to click in the window first and at the
Or
same
maybe it
time.
doesn't work for Windows.
That's a possibility.
Yeah, it works for Windows. Oh yeah, there you go.
So
then you can click that minus.
Probably when the computer was wrong.
Maybe not quite that small.
Let's see if it works on the screen. Okay. So ethylene.
And then click the magnifying glass.
No, I don't want the magnifying glass. That's a pain to deal with.
Okay.
I'm very familiar with that. This works. All right. I'll be going in and out on this so that people in the last row can hopefully read now. Thank you. Who made that suggestion? All right. Tim, right? Thank you, Tim. All right. So, another conditions are specified here. Yeah.
No,
conditions, 90 degrees C, 1.5 atmospheres, and you do that for both the ethylene stream and the chlorine stream. Of course, the ethylene has composition 1 for ethylene, and the chlorine 1 for fluorine. All right. So we have the set, we defined everything on those two streams. Is the reactor ready? No. We need to specify things in the reactor. As a test, actually it's okay to put something in once in the stream we're going to be adjusting. So as a test, to make sure that everything is defined, I'll go to the ethylene stream and I'll put some mass flow rate. So I don't know, we want 46,000 product. That's one component. I don't know, let's put 20,000. So I'll put mass flow rate 20,000 of that. Okay? And this is defined, and notice automatically also the chlorine is defined.
You use 20,000?
Just 20.
Guys, don't do it because I don't know if it will work.
Oh.
Okay.
Don't do it. I just wanted to say that you get blue on both. Okay, if you did it, it's fine. If you did it, it's fine. If you haven't done it, leave it. No problem either way. But you can say that both streams are defined. You can see the temperature is 90, 162 pressure. And you can see the other one, 90, 162 pressure. Okay? But the reactor doesn't give us anything. What have we not yet given to the reactor? The reaction set, that's right. So click on the reactor, go to reactions, and select careful, reactor 1 now, not reactor 2. And what's the duty? I have no idea what duty. What do I know? What temperature? Now we can go to the worksheet and put on the vapor reactor out, which I believe is the same that we will have, 90 degrees. And notice the pressure is automatically the pressure of the feed stream. If I have feed streams of different pressure, what will be the pressure of the reactor? The lowest, exactly. Remember, you cannot have flow from low pressure to high pressure. Also, you cannot heat exchange, transferring heat from low temperature to high temperature. I once had a student who insisted. All right. So we've specified 90 degrees out for the reactor. And that fixes the reactor. And probably I didn't guess very right. Let's see, how much are we making?
Oh no.
We click on that. We click on composition and put. Oh, I clicked the wrong thing. This one. Click that one, click on composition, and put molar flows.
Oh my god. You're going fast.
So how much dichloroethane we make? Oh no, molar flows. I mean mass flows. So how much dichloroethane we make? 10,000, and we need to make like 110, right? So we need about 10 times what I put. All right.
Did you specify, were we supposed to specify a flow in the reactor? No.
I asked you no. If you haven't done it, said no. I put here a 10 times, what value did I put? 20.
20.
Put 20 kilograms. I put 20.
Yeah.
So like 60.
I put 20.
Yeah.
All right. That's. Oh, anyway, let me delete it. Okay. So what's the last thing we need to do?